can do control, measurement, protection, recording data, and all of this could be a smart generation, co-generation, what we call. Then, if you come to the transmission, you transmit from A to B, and then at the substation, you may have the storage there. When there is no peak, no demand, you could store energy. And then it goes to the distribution side, and in the distribution side also, you could try to do some distributed generation where the consumer needs the power. Then, once it comes to the consumer, you have home consumers, you have smart homes, we're going to call them. And we have industrial, and we have commercial building. And we are looking for a gateway, home gateway, a small single chip that costs $5 to $10, a gateway between the consumer smart appliances and the network of information networks. And then we need another gateway. You see here in the homes, you can have some solar energy, you can have some storage. In the industrial, you can have cogeneration, and you can cogeneration from wind, from solar energy storage, and even in the same in the building. And if you have all these together, then you have the industry and residential and commercial areas where they have. This is, for example, substation. As you see, these 10 points where you have people come to your network, and they can hook into the network from remote area, and then they have their devices with them, and then they infect your network. For example, you could have denial of service. In 5 minutes, you can bring the whole GCC networks down. You can delete just a file. You can take control of the SCADA system from a single computer, from your handheld mobile. And this is what happened if you talk about the Starknet virus with just a small flash memory. They stick it off the computer in Iran and bring the whole industrial plant, nuclear plant to ground because of virus. So there is a security issue. Now, who's working in the smart grid? Not just GE only, not the utility companies. Look, IBM, Cisco, GE, Google, Siemens, everybody is joining the smart grid. And this is some starting example in smart grid, where you have in Santiago, you have somewhere in other countries, in the USA, you can now subscribe with Google, and if you have that smart meter, it can tell you how much you are consuming in your dryer at 7 p.m., how much you're consuming in your cable TV, in your outdoor, in your heater, how much is the power consumption through the internet. And even it says, okay, today is Wednesday, September 30, you are consuming 7.4 kilowatts, and if you consume at this rate, you're going to spend about $485, and so on and so forth. So basically, the consumers, one of the examples I read, they said if two consumers, they want to drink their halal beer, let's say, and somebody programmed the refrigerator to keep the drink at 20 degrees, and the other consumer to keep it at 15 degrees. And there is only 1 kilowatt enough for one of the refrigerators. So the two smart devices, they start to negotiate, and they start to bring up the price of the kilowatt. So you need, honestly, also smart devices to control the smart grid. And for example, now, in the US alone, you could save about, if you implement the smart grid concept, you can save 5 to 10% of the power consumption, okay? And in the US alone, its total asset value is more than 800 million. And annual sales are about $300 billion. Sorry, that's 800 million. And the annual sale is what? 300 billion. If you save 10%, you save 30 billion. Okay? Now, what are the challenges with smart grid? The smart grid challenges the scalability so far. So you really have to start with the prototype, small microgrid, and then start to integrate.